Classification of overhead transmission lines. Overhead transmission lines are classified into three types: short transmission line, medium transmission line, and long transmission line. When the length of the line is less than the 50 kilometers, or we can say up to 50 kilometers, and the line voltage is less than the 20 kilovolts, then it is said to be short transmission line. Due to small in length and small in voltage, the capacitance can be neglected in this type of line. And coming to medium transmission line, in which the length of the line is between 50 to 150 kilometers and the line voltage is more than the 20 kilovolts or less than the 100 kilovolts, then it is said to be medium transmission line. Due to some sufficient length and sufficient voltage, the capacitance is presented in this type of line. And coming to long transmission line, when the length of the line is more than the 150 kilometers and the line voltage is more than the 100 kilovolts, then it is said to be long transmission line. And we will see the performance of single phase short transmission line. As we know that in short transmission line the capacitance is absent, so due to that we will consider only resistance and inductance, and we will connect the load. The receiving end voltage will be presented here and sending end voltage is given through this. And this is load. Current is passing through this. Here resistance and inductance is present. So here current is passing through resistor and inductance. Due to resistor and inductance, some drops will be presented here. Due to resistance drop is presented. Due to impedance, the impedance drop is presented here. And we will know that I is the load current and R is the loop resistance, or we can say resistance per phase, and XL is the loop reactance or reactance per phase. And the cos pi r is presented receiving end power factor, and cos pi s is presented sending end power factor. We will see in phasor diagram. And Vs is the sending end voltage and Vr is the receiving end voltage. This is load presented here. So arrow mark will be presented like this. And we will now consider the phasor diagram for the single phase short transmission line. So current is taken as a reference, and OA will, this is the O point, and through this OA will be presented, and this OA will represents the receiving end voltage, which means VR, and this leads the current by the pi r angle. So here pi r is presented, and this OC will represents the Vs. This is the sending end voltage, and sending end voltage leads the current by the pi s angle, and this the AB will represents the IR. Due to resistance drop, the IR is represents here, and we will join, and this is the IXL. Due to reactance, some drop is presented here, that can be represented as IXL, and this will lead the current by the 90 degrees IR. So it is shows like a right angle triangle. So we can write as OC whole square is equal to OD square plus DC whole square. So OD whole square plus DC square. So as we know, OD will be here E is present. So OD is equal to OE plus ED. So OD square we can write OE plus OD whole square plus DC will represent as DB plus BC whole square. And this OA will represent VR cos pi r plus IR. OA and ED. ED we know IR and OA will represent the VR cos pi r. So VR cos pi r plus IR whole square plus similarly DB will represent the VR sin pi r plus IXL whole square. Here IXL is there. IXL. So OC square means OC will represent the sending end voltage. So Vs whole square. Vs square is equal to this equation. So if square is coming this side, it will become square root. So VR cos pi r plus IR whole square plus VR sin pi r IXL whole square, and it will comes under root. This is the equation for sending end voltage, and we will calculate the percentage regulation. We know percentage regulation formula is equal to sending end voltage minus receiving end voltage by receiving end voltage into 100, because we are calculating percentage regulation. And second one is sending end power factor. Cos pi s is equal to OD by OC. OD will represent the, here OD will represent the VR cos pi r plus IR. So here VR cos pi r plus IR by OC will represent Vs. As we know, OC will represent Vs, sending end voltage. So we can write like this. And third one is power delivered. Power delivered is equal to VR IR cos pi r. So here line losses is equal to I square r. Next, power, how much power sent out is equal to how much power delivered plus line losses. As said, VR IR cos pi r plus I square r. So total power sent out equation. Next, percentage transmission efficiency is equal to power delivered by power sent out into 100. So power, how much power delivered? VRIR cos pi r. VRIR by power sent out is equal to VRIR cos pi r plus I square r into 100. So this is the total equations for performance of transmission line.